So let's start. Like I said, we're going to look at acids and bases, and let's start with a typical question. Can you mute your mic, please? Okay, let's look at a typical question here. We'll look at a lot of these type of questions. It says ethanoic acid is an acid that ionizes completely in water according to the following balanced equation. And then the first question that they ask is, write down what is meant or what is underlined, write down the term that is used to underline the phrase above. And ethanoic acid solution has a pH of 4. At 25 degrees, calculate the concentration of hydronium ions. And also, the standard solution of potassium hydroxide is prepared in a 25 centimeter cube volumetric flask. During titration, 12.5 centimeter cubed of this solution neutralizes 25 centimeter cubed of a 0.16 mole per decimeter cubed ethanoic acid solution. The balanced equation for the reaction is provided there, and they ask us to define a base according to Arrhenius theory to calculate the mass of potassium hydroxide used to prepare the solution above in 250 centimeter cubed volumetric flask. And will the pH of the solution in the conical flask at the end point be greater than 7, less than, or equal to 7? And then they're asking us to explain our answer with an aid of a balanced chemical equation. So let's just start with this question. We are not going to dwell on this question. We're not going to try and answer it for now. For now, we just need to look at what are the things that possibly one would have scored marks on, and what are the challenges that learners mainly when it comes to this question or this topic we're struggling with. So if you look at the first question, they said it's a definition. We need to define a term that is underlined there, indicated by that underlined statement. So that's a definition. That's one of the things that I would say are easy things. These are just read off. They are level 1 questions, things that you should remember at the top of your mind. And when it says it ionizes incompletely, that was a clue. It ionizes incompletely. That was a clue that the examiner was providing the students or learners that were writing this paper at the time, that it ionizes incompletely in water. So that means they should have known, or they should know, the definition of what an acid that ionizes incompletely in water is. Now, so that acid, obviously, we will know that it is a weak acid. It ionizes incompletely in water to create a low concentration of hydronium ions. Okay, so that was an easy 1 mark. And then the next statement says, ethanoic acid solution, the solution has a pH of 4 at 25 degrees Celsius. Why did the examiner emphasize 25 degrees Celsius? That was another clue that the examiner was providing them with to say, I want you to use KW, autoionization of water, to calculate the concentration of hydronium ions. And if you look at the equation, you can see that it's a balanced equation. They already told us that it's a balanced equation. If we look at the equation, it says that ethanoic acid would react and produce a 1:1 molar ratio. So that means we do not have to worry a lot about molar ratio in this question. They already told us that it will be a 1:1 molar ratio. So the examiner was providing them with clues, which is also what you are going to see as we go through other preliminary examination question papers, the past preliminary examination papers. You will see that as the examiner is asking you questions, they are also providing you with clues on how to answer such questions. So if we move forward again in 7.2, they are preparing a titration. This is an experiment. So they are preparing an experiment and they are using potassium hydroxide. They are using potassium hydroxide with ethanoic acid. So they are neutralizing, or it's titration of potassium hydroxide and ethanoic acid. Potassium hydroxide was prepared, and here we need to look at the first clue. They say they are creating a standard solution. So that question would be, or the question that one would have would be, what is a standard solution? Is a solution of known concentration and known volume. A solution of known concentration and known volume. So before you dive into a question of titration, you first need to ask yourself, what is my standard solution? Before you can even do anything when it comes to a question of titration, you need to know what is your standard solution, because that solution provides a path for you to travel as you are trying to answer the questions that will follow. It is that solution that will give you an idea of what needs to be done. All because you have its concentration and you also know its volume, then that means it makes it easier for you to calculate whatever the examiner might be asking you. And if you go further and you look at the type of question, they say they are preparing, and I always emphasize this with the learners, with my learners as well. There are a lot of volumes if you look at these questions. It has a lot of volumes. Well, when it comes to titration, the examiner uses these volumes to confuse or to divert or to check your understanding of what was talking about or what they are talking about. So they prepared 250 centimeter cubed solution of potassium hydroxide. It is just like you saying you are going to the store and you are buying a 2-liter bottle of cold drink. The contents of that bottle is 2 liters of Coca-Cola. Now, that's the content. But what you consume is not 2 liters. We need to be careful when it comes to that. You buy 2 liters, but what you consume at home is not 2 liters or 2 liters. You are consuming a glass. Maybe the glass may be 250 centimeters cubed or 250 milliliters, but you are consuming a glass. So this 250 is placed there to divert you from what is actually required for your calculations or for your answer. But there is a way in which, or there is a trick in which you can use to understand which volume or to remember which volume you must use for that question. Now, okay, so they prepared 250 centimeter cubed volumetric flask. During titration, 12.5 centimeter cubed of this solution, and I want you to listen to that, 12.5 centimeter cubed of this solution. Of which solution? The 250 centimeter cubed. They only used, this is what was used. They only used 12.5 centimeter cubed of this solution to neutralize to neutralize 25 centimeter cubed of a 0.16 mole per decimeter cubed ethanoic acid. Now, if you look at just the introduction or the statement, if we look at the statement, we are given the following. We are told that for ethanoic acid, I have the volume that was neutralized. I have the concentration. And for potassium hydroxide, I have nothing. However, we do know that it's our standard solution. What I know is that I have volume. And if you recall, if you go back to your data sheet, you will see that there is a formula there that says number of moles divided by number of moles is equal to concentration times volume divided by concentration times volume again. Now, so these number of moles that we are referring to, we find them in our molar ratio, meaning in the equation. And if you look at our equation, it's a 1:1 molar ratio. So that means there, you will substitute 1 and 1. Now, the tricky part comes on that side. On the other side, what we can see is that already for the acid, I have concentration. For the acid, I have volume. For the base, I only have what was used, the volume that was used. I have that, which tells me I'm able to calculate concentration. We haven't even dwelt or went deeper into. They say there is a hand, so we have a hand. Yes, who there is a hand, please unmute yourself, just talk to me. Okay, maybe it was a previous hand. Ne? Let me move forward, but feel free. However, this will to make this easier because okay, Nkani, unmute and talk to me. Just to make this easier so that we do not have a lot of disruptions. Ne? When you unmute to talk to me, unmute, talk, and then mute again so that we do not have a lot of background noise. Ne? So just unmute, talk to me. You don't have to raise a hand, just unmute, talk to me. And then once we have addressed you, remember to mute yourself. Because at the end of the day now, I will have to request them to mute all of you. And that takes time on its own. Okay, as we were, so what I was saying was, if we just look at that statement alone, we already have a lot. So we are able to answer a lot of questions here without even looking at the questions that the examiner asked. Anyway, moving forward. So what does he say? The examiner wanted them to define now a base according to Arrhenius' theory. The examiner asked them to define a base according to Arrhenius' theory. And obviously we know it's a substance that would liberate hydroxide ions in water to produce the concentration of hydroxide ions, okay? So that was also an easy 2-mark question. Then they say, calculate the mass of potassium hydroxide that was used to prepare the solution above in the 250. Yes, now they want you to go back. In the 250 centimeter cubed volumetric flask for 7 marks. For 7 marks. So for 7 marks, they say calculate the mass of potassium hydroxide. Okay, for 7 marks, we are going to come to that. We're going to come to that. Let's move to 7.2.3 says, will the pH of the solution in the conical flask at the end be greater than, smaller than, or equal to? Now here, they want us to look into hydrolysis or hydrolysis of, so that is a question on hydrolysis. So the remaining 4 marks is for the salt that was produced at the end of the reaction. The remaining 4 marks, that was for the salt that was produced at the end of the reaction. So it has nothing to do with 7.2.2. Okay, so if you were the one sitting in that examination, or if I was the one sitting in that examination, and I'm not comfortable with acids and bases, would it be possible for me to score marks in this question? Would it have been possible for me to score marks? And if that was the case, how many marks would I have scored out of this question? Okay, let's start. We look at the typical things. We start with the basics. We say, am I able to define all the terms and definitions that are provided in this topic? Yes, I'm able to do that. I can read that. So that means I'll be able to score 1 mark there, and I'll also be able to score 2 marks there. So that's 3 marks. So that's 3 plus 5. The next question is, am I able to calculate concentration? It doesn't matter what type of concentration. Am I able to calculate concentration? This is also a level 2 question that says, for just interest's sake, know how to calculate concentration. And yes, it's not difficult to calculate concentration. So that means 3 marks there, I can score. The next one would be, do I know hydrolysis or hydrolysis? This is also not something that is tricky for me. So, because it requires me to know the types of acids and bases, and then from there it's just a straightforward reaction. If I know the strength of acids and bases, then it will be just a straightforward reaction. So that means I can be able to score those 4 marks there at the bottom. And that would give us 10 out of 17. 10 out of 17 is more than 50% of this question. 10 out of 17 is more than 50% of this question. So that means you would have been, or I would have been able to score a lot of marks without going into a difficult question, 7.2.2. And it's not really that difficult. There are also things that we can do for that question that we can score a lot of marks on that 7 marks, even if we don't get the whole 7 marks. But we should be able to score a lot of marks from that 7 as well, because not all of us will be able to get to that 7, but we can get at least 4 marks out of that 7. So that is what you and I are going to be looking at today. We are not really teaching, so we are going to look at what are the things that you and I can learn. What are the things that you and I are saying to one another? It doesn't matter what, even if I get a question that says 9 marks, out of that 9 marks, there are things that I can still do. There are skills that I still have learned that I can score marks from. And this will enable me to score 50+% on my final examination. So that's the things that you and I are going to do. We are going to try and explain briefly. We are not going to dwell deep into explaining and reteaching. We are going to teach briefly, but most of the time we're going to spend it looking at what skills can we use. We have taught, teachers have taught you. What is left now is for you to know the skill that is required for you to pass with at least a minimum of 50%. Okay, I'm going to move forward. Like I said, when we started this, I'm not going to answer this slide. We are not going to answer it. You can attempt it. It was a national paper. You can attempt it. After this presentation, you can go back and try and answer this. Try and answer these questions. Use some of the things that I've highlighted here to guide you. Okay, so let us quickly go through the content that is required. And here we are going to talk about the must-knows. We are going to highlight the must-knows, the things that we are saying, Noma Kanjani, everybody sitting, watching this presentation, at the end of the day today, these are the things that we are going to start working on. The first one is we need to get our terms and definitions out of the way. By now, you should know the importance of terms and definitions. You should know by now that they are very important. So this is a must. We must know how to define an asset according to the two theories, Laurie-Bronsted theory and Arrhenius theory. We must know. It's a must. About 60% of the time, you will get a question that wants you to define, because the topic is about acids and bases. So you will get a question that would want you to define an acid or a base. So you will get a question. So it's a must for you to know the definition of what is an acid and what is a base. This is a must. I cannot emphasize it better. This is a must. It's a must know. So we must know how to define an acid and base according to Laurie-Bronsted theory and Arrhenius theory. There is a trick. For Laurie, just know that he's talking about, or they are talking about, the proton donation. It's about proton donation. Proton donation, that's what they are based on. And then here, they are based on products, hydroxide ions and hydronium ions. Now, Arrhenius is based on hydroxide ions and hydronium ions. Laurie is talking about proton donation. Okay. The next part is another definition, a must know. The next thing that we must know is another definition. So that means it's a must. Like I said, the topic is acids and bases. So that obviously the examiner is going to ask you to define an acid or a base. They are going to ask you to define them. Now, so here they are talking about strength. Distinguish between the strength of an acid and a base. The strength of a strong acid is a substance that ionizes completely. There is one thing that learners always forget to emphasize or to put in their definition, and that is to produce a high concentration of hydronium ions. Please don't forget that. You will lose marks unnecessarily. You don't have to lose marks unnecessarily. It's a substance that ionizes completely, and it produces a high concentration of hydronium ions. Some of us are lazy. We do not want to study. At least learn what a strong acid is. Learn what a strong base is. Because the opposite of what a strong acid is and the opposite of what a strong base is a weak acid and a weak base. The only thing that's changing in their definitions, and I'm going to show you, is that it ionizes completely in water to form a low concentration of hydronium ions. So if I know the definition of a strong acid, then I will also know the definition of a weak acid. Now, because it's just in and low. The same thing with the base. It dissociates completely in water to produce a high concentration of hydronium ions, or hydroxide ions rather, the same as a weak base, dissociates incompletely in water to form a low concentration of hydro hydroxide ions. I'm going to say it again. This is a must know, meaning this definition is a must know, and these definitions are a must know. If we go back to our first slide, the first thing they asked us was exactly that, to define an acid. The second thing they also asked us was to define a base. So that says to you and I, it's a must for me to know how to distinguish them or to define. Okay, now, it also now moves to concentration, and I'm going to stick here a little bit. They say distinguish between concentrated acids and bases and dilute acids and bases. We have a problem, and this problem is that people don't really know what these words mean. We have a problem, and the problem is that people don't actually know what these two words mean. Concentrated and diluted. Now, people confuse concentrated with concentration. People that confuse concentrated with strength. And I know why people would confuse them. Because we say a strong acid produces a high concentration. That means if an acid is weak, it will not have a high concentration. But that's not true. And that we need to clarify, that it's not true. A weak acid can be concentrated. A strong base can be diluted. So the word concentrated and the word diluted refers to the amount, quantity of particles. So let's take an example. My favorite drink above all of them is Oros. I don't know if I have people who enjoy Oros like me as well on the other side, but I enjoy Oros. The orange juice. It's nice. I love it. That's my favorite juice. That's my go-to cold drink. If you and I were to choose what to drink, I would go for Oros every time. It's the best. Now, to prepare Oros, I have to mix the juice with water. I can't drink the juice directly from the bottle. As when I buy it, it's 2-liter concentrated, or it's a 2-liter concentrated orange juice. If you drink that 2-liter concentrated juice, it does not taste nice. It is concentrated, so that means inside for per unit volume, it has a lot of particles, a lot of those orange juices, orange particles inside. It is highly concentrated. It's not sweet. When you get home and you have something like that, taste it, you will see. It is not sweet. It is acidic, it's bitter. So it has a lot of particles. So per unit volume, there is a lot of particles. But if I mix that, a small amount of it, 1:4 ratio, meaning 1 milliliter would make 4 milliliters. If that's what they're saying, that I can create a 5 milliliter solution or juice. And from that 1 milliliter to, I'm diluting it. That is concentrated. So when I pour in water, I'm diluting it. And when I dilute it, it means per unit volume now, it will not have a lot of particles. Now, dilution means we are increasing space. It says we're increasing space between particles. Concentrated means you are cramped inside a bus. It's not nice to be cramped inside a bus or inside a room. There is not enough space. So when we dilute, we create space. We create space. When it's concentrated, there is no space. So concentrated solution refers to the amount. When we talk about concentrated and diluted solutions, we are referring to the amount per unit volume. The amount per unit volume, the number of moles per, but the number of moles will remain the same. Number of moles remains the same, it's just that volume now is being increased. Are we together? And that would mean, and if we go back to grade 11, concentration is number of moles divided by volume. So that means the relationship between concentration and volume. I hope you heard the difference. The relationship between concentration, not concentrated. The relationship between concentration and volume is that they are inversely proportional. So that means if we increase volume, we're keeping number of moles constant, we will be decreasing concentration. I hope I tried to explain it better, but this is also very important for you to understand. It is important because the whole topic is based on solutions. So that means for solutions, we must know concentration. The entire topic is based on solutions, and for solutions, we must know concentration. So it's a must. It's a must know. Okay, so they are also moving to say, this is from your examination guideline, by the way. It says that we need to also know to write down reaction equations of aqueous solutions of bases and acids. And this is where they put in another definition, what is a monoprotic and what is a diprotic acid. A monoprotic is an acid that is able to donate 1 proton. A diprotic is an acid that is able to donate 2 protons. And where do we find them? There, it has only 1 hydrogen. There, it has 2 hydrogens. There. So it is able to donate 2. This refers to molar ratio. Why? 1 mole of sulfuric acid will produce 2 moles of hydronium ions, whereas 1 mole of hydrochloric acid will produce 1 mole of hydronium ions. So 1 mole or 1 molecule produces 2 and 1 molecule produces 1. So that means if you have the same amount, if you have 1 mole of hydrochloric acid and you also have 1 mole of sulfuric acid. They are both strong acids, by the way. They ionize completely. So that means if we come to our products, you're only going to have 1 mole of hydronium ions, whereas on the other side, you're going to have 2 moles. That means this solution, the reaction of sulfuric acid, will be more concentrated. Heard that? Ne? It will be more concentrated than hydrochloric acid. It will have more particles per unit volume as compared to hydrochloric acid. Okay. Moving forward, trying to run and not waste time as well. Now it comes, oh, this is something nice. 3 marks. It's just 3 marks. Conjugate acid-base pairs. Here they want us to know how to identify conjugate acid-base pairs. This is just 3 marks. This is just 3 marks. 3 marks. You don't even have to scratch your head. This is just a direct free. Now, a conjugate acid will have a proton more, and a conjugate base will have a proton less. So that means if I have HCl, its conjugate will have a proton less. That will be Cl minus. I have to remove 1 proton. If I have Cl minus and I tell you that this is a base, then its conjugate will have a proton more, additional proton, that will be HCl. A conjugate acid will have a proton more, and a conjugate base will have a proton less. Those are just 3 marks. That means this is a must. It's a must know. It's a must. It's something that we must know. I hope you are writing down things that you must know. Okay, moving along. It says also we need to know how to define a noun for light. That's another definition. It's a must. You must know how to define a noun for light. It's a substance that can act as either an acid or a base. That is what we call an ampholyte. So, examples of ampholytes. Most of the time when the examiner is asking you to look to identify an ampholyte, yes, water is a good example, but you must look at the reaction. You do not cram. You can't cram examples of ampholytes. You can't. It's impossible. Well, it's possible, but it's impossible for you. You don't have to, because that's not how the examiner is going to ask it. He's not going to say, identify an ampholyte at the top of your head. No, he's going to give you a reaction and want you to look at that reaction and look for the substance that acts as an ampholyte in that reaction. So do not cram when it comes to ampholytes. Look at the reaction. Which substance started as, let's take an example quickly, SO4 plus water. The reaction will first react to produce, obviously this will donate a proton, right? And then we have HSO4 minus plus H3O plus, correct? Fine. And then we are taking that SO4 because it's incomplete. The reaction is not yet completed, and we are reacting it again with a water molecule, and this gives us SO4 2 minus plus H3O plus. In this reaction, the examiner wants us to, let's say he's saying, identify an ampholyte. So what do we know? We know that this, because it's losing, you observe it. H2SO4 is an acid. Why? Because it's donating a proton. If you look at it that side, it's donating a proton. So it donated a proton, that means water becomes a base. Okay, fine. And then on the other side, this now becomes a conjugate. This guy is now a conjugate. Their relation, they are now conjugates. It has now lost a proton, so that means it has become a base. And if that is a base, then water would have to be an acid. They work in pairs. Okay, the hydronium ion there is a base, is an acid. And then when we come to the second reaction, what we see there now, this guy starts as an acid. Water is a base. Why do I say that? Because it's losing. So water becomes a base. This guy is donating a proton there, and that therefore, this is now a base because it was an acid, and that is now an acid. Then, in this reaction, water is not, H2O is not an ampholyte. But it's a good example of an ampholyte. But it's not an ampholyte. So why do I need to claim that water is a good example of an ampholyte? Because the examiner will not ask you. He will not ask you to, at the top of your head, identify an ampholyte. Or give me an ampholyte at the top of your head. They will ask you to identify it in a reaction. So let's look at our reaction. And if we look at our reaction, this substance there, this guy here, is changing. It's changing sides. On one reaction is a base, on another reaction is an acid. So in this reaction, this is our ampholyte. Okay. So they say you should also know how to show that a substance can act as an ampholyte. I'm just giving you a demonstration there. Okay, moving. We must also remind you that, which is what I just said. A conjugate acid, we add a proton. A conjugate base, we remove a proton, which is just what I've just highlighted. Know that. Know it is a must. I have highlighted it on that side, but I'm still going to highlight it again. It's a must. It's a must. I said it before. It's a must know. Easy to mark. So this is a must know for you as well. Know that a conjugate acid and a conjugate base, we add a proton for acid, we remove a proton for a base. A proton, hydrogen. Hydrogen atom is what we know as a proton. Okay, moving right along. And then these are neutralization reactions. Please, this is from grade 11. You are now in grade 12. So these are the things that you should know by now. You are in grade 12. It's time you act like. You must know how to write these reactions. It is necessary because from these reactions, you must know how to do them. Write them down because it's from these reactions that you are able to hydrolyze. So hydrolysis comes from these reactions. This is where you get your salts. The salts that you hydrolyze come from there. So please, and if you look at your examination guideline, it gives you a very good number of examples of these reactions. Just know those at least. Just know how to do those. At least know how to do those, not new ones. Now, okay. Then we move on. It says calculate pH. We must be able to approximate pH. I'm going to tell you how to approximate it. This comes from reactions of when choosing an indicator. This will give you a good approximation of pH when choosing an indicator. So this is also going to be a must for us. It's a must. When choosing an indicator, we must be able to do hydrolysis. We fine? Okay. And then it says define hydrolysis, which is a reaction between salt and water. That is out of the way. It's also a must know. It's a definition, so it's a must know. And then from there off, they want us to look at this. It says, according to hydrolysis, a weak acid and a strong base, when they react, the pH of the results will be greater than 7. That means the solution will be basic. You heard that, ne? Okay, so that means you must know how to identify strengths or acids to say this acid is strong, that one is weak. We must know that. So let's quickly just go through that. It says if I react a weak acid, that's a weak acid with a strong base. With a strong base. If I react a weak acid with a strong base, my solution becomes basic. If you are in the playground with your friend and your friend is stronger than you, we all know who's going to possess or going to take the toys to themselves. So think about that in that fashion, that you have one weak person and another one is strong. If they were to fight, which we are not saying they should, but if they were to fight, the strong one will win. Now, that's what it says here. If I have a strong acid fighting with a weak base, if I have a strong acid fighting with a weak base, I think it's fair to say the strong is going to win. You can imagine you fighting, who was that guy who, the boxer, who was famous a few years back, Floyd Mayweather. If you were to fight with Floyd Mayweather, we will both know Mayweather is gonna win. So the strong will always win, which is why this solution becomes acidic. And in the pH scale, acids are at the bottom there. From 7 downwards, that's where you find acids. From 7 upwards, that's where you find bases. That's how you approximate the pH. Okay, and then if we fight, if two strong people fight, normally the fight ends in a draw. And if a weak person fights with a weak person, normally the fight will end in a draw, which is why the pH of the solution becomes 7. Now, please, this is also a must. These are easy marks. Hydrolysis is an easy mark. Okay, I have only 15 minutes left. so that we can start. So I'm going to try and push faster. Okay. We have 3 specific indicators that you must know. You must know methyl orange, phenolphthalein, and bromothiamyl blue. Which indicator do we use for which reaction? Simple. Mine says my beautiful princess. I have 3 daughters. So these are my princesses. My beautiful princess. M stands for methyl orange. And where do we find methyl orange? We find methyl orange when the solution is acidic. It's the first one. So if you have numbers 0 to 40 and 7 is the middle, the first number, or you can see the first set of numbers belong to acidic solution. And what is an acidic solution? We said it earlier. We said an acidic solution will be, we find our acidic solution when a strong acid reacts with a weak base. So that means right here, I have to use methyl orange. Okay. My thingy here. Okay. And then the next one on the beautiful side. Who's beautiful? Beautiful is bromothiamyl blue. Now, on the beautiful side, we have bromothiamyl blue. Bromothiamyl blue, we find it in the middle. So that means this is when the solution is neutral. And why do we find neutral? We find neutral in the middle. That's where we find 7. So meaning between 0 and 7, that's where I find my acidic solution. Neutral, that's at 7. And then princess is the last one. So that means princess will be basic. And princess, if princess is basic, that is between 7 and 14. You just choose a range. Don't choose a difficult range. Ne? I always tell mine to say, keep it PG, man. Just go 9 to 12. Here is 7, so just go 6, between 6 and 7, or 6 and 7, comma something. And then there, I will just keep it at 3 to 6. You see, just play around with your range. Don't be too strict when it comes to your range. Okay. And then from there off, it gets to titration. Now, these are what is an equivalence point? We must know how to define it. We must know also how to define endpoint, and also the part of stoichiometric calculations. I'm also going to show you where are the marks in stoichiometric calculations, and what are the easy stuff when it comes to stoichiometric calculations. Okay, so that's the point where the indicator changes color. That's the end point when the indicator changes color. Equivalence point, that's a point where an acid or a base has completely reacted with the other. Okay, so these are must-knows. These 2 definitions alone, they are must-know. Let's just get the theory part out of the way. Okay, and then moving right along, it says now explain the pH scale as a scale of numbers from 0 to 14 used to express acidity and alkali solution. I've done that on the other side. Yeah, I've already done that on the other side. Now we are coming to stoichiometric calculations. Stoichiometric calculations that we have, I said, this topic is about solutions, and in solutions, we must know how to calculate concentration. It's a must know how to calculate. It's a must know how to calculate concentration. It's a must. It's a must know for us to know how to calculate concentration. And this auto-ionization of water, I can't stress it enough. That is very important. We indicated it earlier. This is 25 degrees Celsius. I said it earlier in that question that we were looking at the beginning, that the examiner was pointing you in this direction. First, come and react your acid with this water so that you can get the concentration that you are looking for. Okay. So we are going to have a lot of discussions on this. I just want to push it so that we are able to actually get to the fun stuff. Okay. And then it says, explain autoionization of water. That's what we say. Water reacts water molecules react with one another automatically without anything, because water is an ampholyte. It can be an acid and it can be a base. So the molecules inside there will react with each other. Now we get to Ka and Kb. Ka value is ionization constant and dissociation constant. I'm going to have to skip it a little bit because there are things that I want to highlight here. Yeah? But the greater the Ka value, the stronger the acid. The greater the Kb value, the stronger the base. Yeah? But we will just skip it for now because I do have some examples that I need to explain to you, to show you, that will explain this much better for you. Then it says compare strong and weak acids by looking at pH, conductivity, and the reaction rate. We fine? Now, this is just to distinguish. We have already spoken to that. Monoprotic and diprotic acid, one single proton donor, the other one is a dual or two proton donor. So that one is out. Conductivity. Conductivity here refers to its ability to conduct electricity. Now, a concentrated solution is ionic, and a more concentrated solution, ionic solution. If an ionic solution is concentrated, it will conduct electricity. And in the definition of a strong acid and a strong base, it says it produces high concentration of hydronium ions and hydroxide ions. So that means strong acids and strong bases are good conductors. They are good conductors of electricity, whereas weak acids and weak bases will be weak conductors of electricity. But this is not talking about concentrated. It's just talking about the strength of an acid and the strength of a base. It's just on that. It's not talking about a concentrated solution or a diluted solution. I hope you understand that. It's just referring to the definition that we know of what is a strong and what is a weak. Okay. And when it comes to reaction rate, this one we did it in term 2. I think we did it in term 2 on March there. The rate of reaction, one of the factors that affect the rate of reaction is concentration. Now, concentration is the number of moles per unit volume, amount of substance per unit volume. So if a strong acid produces a high concentration, that means it has more atoms. And if it has more atoms, then particles are able to interact. More particles will be able to interact with each other, giving out a higher rate of reaction. Yeah. Whereas with a weak acid, it has less particles. Yeah? So that would mean it will have a low rate of reaction. Strong will have a high rate of reaction. Weak will have a low rate of reaction. Okay, moving right along. Now, this is what I wanted to highlight to you. It's speaking to conjugate acids and conjugate bases. In the free stage last year, this is the paper they wrote on. These are the questions that come from acid and bases. These are the questions that they wrote on acid and bases last year. They said, write down the conjugate base of HClO4, right? We already said this is a must know. We already said this is a must know, and we also said a conjugate acid, you add a proton. For a conjugate base, you remove a proton. So let's look at our formula. Whoa, there is that guy. Okay. And he is able to only donate. He only has one proton. So if I remove this proton, what am I left with? ClO4. We just need to look for ClO4 here. There it is. 2 marks. You see? free 2 marks. Not that difficult. Physics is not that difficult. It's just us who make it difficult. A solution of sodium hydroxide. A solution of sodium hydroxide. Ne? Yeah, you go through. The first option says transbromothymol blue yellow. I don't know if you know. The second one says it's acidic. This one is out. It's sodium hydroxide, so it's not an acid. So B is out. Turns phenolphthalein to colorless. We don't know. We don't know yet. But what we do know is that it is basic. You will not get 2 answers that are the same in multiple. That will answer that question in multiple. You won't. So if it's basic, it is basic. You choose basic. You leave out the color there. Because this solution, we know it is basic. So the examiner will not give you more options. They will give you an option that comes close to the answer, but it's not the answer. But one of them is the answer. And for now, in this instance, it is basic. Maybe you can go back and look at what color bromothymol blue would give. But I can also tell you what color it will give. If we have a basic solution, bromothymol blue will turn blue. It will be blue for a basic solution. And phenolphthalein will be pink for a basic solution. Next. That is what we need to know. Okay. So if we look at the 2 options, this was 4 marks, free 4 marks, free stuff. And let's move on. Okay. And then this was the question paper that they had to answer. Now, we are going to start by looking at what were the things that we said we must know how to do. And did they score marks on that? If we know the must, let's start with the must. What is hydrolysis? Is a definition we said we must know. So 2 marks is in the back. You must know 2+. Let's move. Will the final solution be acidic or basic? We said this is easy stuff. So if you read the question, it says hydrochloric acid, which is a strong, reacts with ammonia, which is a weak. So acid will win. So that means the solution will become acidic. 1 mark, free mark, 1+. We move on to the next one. Write down the balanced equation for the chemical equation that explains your answer. Now we are coming to it. It says we should write down a chemical, and I said hydrolysis is a must. It's a must for us to know. So let's write it down. The reaction that we are writing down, I don't have enough space, so I'm going to wipe something here. I'm going to just erase a little bit. Remember I said you should mute, and only unmute when you are talking to me. Please mute. Okay, so let's move. It says write down the chemical equation that explains your answer. Hydrolysis is a reaction between a salt and water. And what is our salt? The salt is that product there. So we have a salt that is NH4, okay? And Cl minus. Oh, sorry, Cl. Okay, so where does the NH? We already saw it. NH comes from NH3. NH4 comes from NH3, which is a weak base. Fine. Okay. And then where does this guy come from? This guy comes from a strong acid, HCl, which is a strong acid. We fine? Okay. So here is something that you can use. Strong people usually have weak children. If you were born with a silver spoon, your child will suffer the consequences of you being born with a silver spoon, because your child does not know how difficult it was. So a strong acid will produce a weak base. Strong produces weak, and weak people produce strong people. So strong produces weak, weak produces strong. That's what we must remember. And the weak do not hydrolyze. No hydrolysis. The weak do not hydrolyze, so we are sorted. Now we come back to this. This guy comes from a weak, so that means this guy will hydrolyze. This one comes from a strong, that means no hydrolysis. So the reaction of Cl- and H2O will not happen. No hydrolysis. But the reaction of NH4 and water, NH4 and water, let me just write it on this side, sorry. The reaction between NH4 plus and water will take place, and NH4 is a conjugate acid. This was the base, so NH4 becomes a conjugate acid. So what does an acid do? It donates a proton. And what will it produce? H3O plus NH3, going back, plus NH3. But this is what we are looking for. Which means we are going to have, if we compare the concentration of H3O plus to the concentration of OH minus, if we compare the two concentrations, we can see that the concentration of H3 plus will increase. So we have more H3O plus compared to OH minus. So the solution, because this concentration of H3O plus is greater than the concentration of HO minus, then our pH there, we say our solution becomes acidic. And where did we learn that? We learned that when we were talking about definitions, that an acid is a substance that produces hydronium ions in water. So we have hydronium ions, so that means the solution is acidic. And where is our pH gonna be? Our pH will be less than 7. We have answered that. We have answered that. That 3 marks is in the bag as well. We fine? Okay, so that means 6 marks was from the must knows. 6 marks was from the must knows. Okay, and then they say for the above titration, 25 centimeter cubed of a 0.1 mole decimeter cubed NH3 solution is titrated against 40 centimeter cubed HCl solution. We fine? Okay, they are saying 25 centimeter cubed of a 0.1 mole decimeter cubed solution, sodium ammonia solution, is titrated against 40. You see that? You see that stuff? Okay. Here we are given volume. There we are given concentration. And for the acid, we are also given volume. You remember when we started, I told you this stuff are easy. And you can see now these stuffs are easy. We are getting to the core duties of stoichiometric calculations. Okay, it says, is HCl a strong or a weak acid? We have already stated it above. It is a strong. So 1 mark, it's a strong acid. Explain your answer. They don't want you to explain your answer. They don't want you to explain. Hey, we don't want you to explain your answer. We want you to define a strong acid. They don't want you to explain your answer. They are actually asking you to define an acid. And when you define an acid, a strong acid, it's a substance that ionizes completely to produce in water, to produce a high concentration of hydronium ions or H plus ions in that solution. Now, so they are not asking you to explain yourself. They are just asking you to define it. So they say, write down the name of the indicator that is suitable for this reaction. Born, easy marks. Indicator suitable, we said the solution will be acidic. There it is, less than 7. You call back and say, well, I have a beautiful girl, my beautiful princess. And this is 7. So what is less than 7? Methyl orange. You have already answered the question there. That's methyl orange. 1 mark. Next, explain your choice of indicator. Why did we choose this indicator? We are choosing it because the reaction is between a weak base and a strong acid. Why did we choose it? The reaction is because we are reacting a weak base with a strong acid. And then they say calculate the number of moles of ammonia in 25 centimeter cubed of that ammonium solution. We are here. They are asking you to calculate number of moles. This basic. It was basic from grade 11. That was basic from grade 11. It was the basic. And it was one of the things that I said we must know how to do, how to calculate concentration. We must know how to calculate concentration. So here they are asking us to calculate concentration. We have concentration is equals to number of moles over volume. It's a must for us to know. And then what is concentration? We have concentration is 0.1. That's 0.1 is equal to, we don't have number of moles divided by, what is the volume? 25 centimeter cubed. So that will be 25, which we must convert. So we multiply it by -3, 10 to the power -3, and then we get our number of moles being equal to, you see, 0.1 times 25 times 10 to the power -3, and you get your answer there. Get your answer. Easy. So that means 3 marks was also in the bag. And then they say calculate the pH of the final solution. I'm going to give you at least 5 minutes to just do that, to calculate the pH of the solution. I'll also tell you the steps that we must follow. I'll also tell you the steps that we must follow. But let's take 5 minutes for you to attempt this question before we conclude it.
What's the problem? We can't hear you. Hello?
Okay, I'm back. Let's talk about calculating the pH of the solution. I'm going to give you steps that you follow when calculating. This is one of the most common questions in acids and bases. It's one of the most common questions. So that means we need to know what are the steps that we must follow. The first step will be the obvious one, identifying the limiting reagent. But in this reaction, they said both of them were titrated. So that means we do not have a reactant that will be in excess. We will not have a reactant that is in excess. But the pH of the solution is normally determined by the reactant that is in excess. So in this instance, we don't have a reactant that is in excess. So the pH of this solution will be determined by the salt. Are we fine? Okay, we are sorted that one. So step one, we then know that both of them are going to neutralize. Okay. Now we just need to calculate the concentration of hydronium ions. So let's look at the marks. But before we get to this marks, let's just quickly get how much did we receive. Let's calculate how much we would get before we answer 7.2.6. Okay. We said 6 marks will be in, so that is 6 plus. We said 1 mark and 2 marks, that's 3. So plus 3. Correct. We also said choice of indicator is a must know. That will be plus 1 plus. And then you go to explaining your answer, why. That is also something that we must know. That will be 2. We're fine. And then we also highlighted that it's a must for us to know how to calculate concentration. So that child who was sitting for the examination last year would have been able to get, without question 7.2.6, that child would have been able to get 6 plus 3 plus 1, that's 10, plus 5, that will give us 15 out of a total of 23. You have calculators there. You can see that 15 out of 23 is a lot of marks. It's higher than 50%. So they would have been able to do that. So where are the marks in this question? The marks is calculating number of moles. You get marks by calculating, for just calculating number of moles. That's where you will score a lot of marks. Okay? You score a lot of marks by just calculating the number of moles. So even if you don't know how to attempt the question, the least you can do for yourself is to calculate number of moles. Okay, this is the memorandum to that question that we were answering earlier, just now. And then here we are, calculating pH of the solution. We're fine. Okay, we did say calculating number of moles will be important. So we have number of moles. We're fine. We have number of moles of sodium there. We have one number of moles of the acid there. We good? Okay. This comes from which guy? This comes from that. Concentration of hydrochloric acid. There. That's where it comes from. Okay. And then from there off, it says you must be able to substitute. Okay, we did that. So we get to Kw. Once you have concentration of the acid, you then move to Kw. This is Kw here. Autoionization. You use autoionization of water to get the concentration of hydronium ions, and then from there you calculate the pH of the solution. So here we did have something that was in excess, and hydrochloric acid was indeed the one that was in excess. Okay. Moving right along. We are not going to attempt difficult questions. We are just going to attempt where we are going to get marks. For now, let's get marks. Let's get the easy stuff out of the way. For this try, just get the easy stuff out of the way. Know the easy stuff so that when we go to your final, that's when you start to attempt now the most difficult questions. Right? But for now, let's get the easy stuff out of the way. Let's pass things that are simple. That's how you build confidence. Pass small achievements, build confidence. So here are some of the multiple choice questions. This one we have already answered. 1.2 we have already answered, but 1.1 says, which positive ion must be present in an aqueous solution of an Arrhenius acid? Which positive ion must be present in an aqueous solution of an Arrhenius acid? We find? Okay. And the answer there would be the definition of an acid. What is an acid according to Arrhenius theory, which we said is a mass? No. It's a substance that produces hydronium ions in water. So the answer there is D. Simple. It's a definition. 2 marks. Easy 2 marks. A solution of sodium hydroxide, we did answer this one as well. We answered that. We said conjugate base is C, and then this solution would be basic. Okay, let's move. And then it says a 0.2 moles per decimeter cubed solution of sodium hydroxide in water will be a better conductor of electricity than a 0.2 mole per decimeter cubed ammonium solution in water, because the sodium hydroxide solution, water. Now, remember, conductivity, I did say, conductivity is based on strength. Ne? Sodium hydroxide is a strong and ammonia is a weak. Fine. So a strong would produce high concentration of ions. Ne? A weak will produce a low concentration of ions. So the answer to that question would be a strong base contains more ions than ammonia. A strong base would contain more ions than ammonia. Okay, the following equilibrium exists in pure water at 25 degrees Celsius. Please remember, I did say, the moment you see that, they are telling you to use auto-ionization of water. At this temperature, the pH is equal to 7 and Kw is equals to 1 times 10 to the power negative 14. The temperature is increased to 90 degrees Celsius. Which one of the following is true at the new temperature? We fine? Okay. Now look at what is happening at equilibrium. Now, what is happening is that we have a liquid which will not be affected by this equilibrium shift, but we have these ions in our products that are affected by equilibrium shift. Good? Okay. They say forward reaction. Forward reaction is its enthalpy is greater than 0. So forward reaction is endothermic. And what did they do? They increased temperature. So that means they are talking to a reaction that wants that increase in temperature. We fine? Okay. So here are the answer to that question would be B. The answer to that question would be B. The concentrations will still be the same. The concentrations will still be the same. The reaction will just be shifting to produce products. But these are the only guys who are there. So concentration will only be there to the product. So the answer to that question is B. Okay. And there they are. the options that we were talking about. Moving right along, let's quickly get to Limpopo. Now we are driving to Limpopo. In Limpopo last year, this is what they asked them. Is sulfuric acid a diprotic acid? Is a diprotic acid, define an acid in terms of fluoride prostate theory. That's 2 marks. We said it's a must know. 2 marks. We're good? Now, it's a proton donor. Okay, give a reason why sulfuric acid is a diprotic. That means they want you to define diprotic. That means it is able to donate 2 protons. You see, 3 marks in the back. Fine. Then 7.2 says the hydrogen carbonate ion can act as both an acid and a base. Underlined there, both an acid and a base. That underlined phrase there is an ampholyte. It's another definition that we said we must know. It reacts with water according to the following balanced equation. There it is. It is reacting with water in that balanced equation. They say write down the word for the another underlined phrase. That is, the word is ampholyte. Good. HCO3 minus acts as a base in the above reaction. Yes, that is true. We can see it. Let's look at it. There. It has gained a proton. So it acts as a base. Write down the formula of the conjugate acid. Acid. Remember, we said if it's an acid, conjugate acid would have a proton more. Proton more. And there, they've already given you the answer. They just want you to take it from the question paper. H2CO3. So that's another mark. So in this part of Limpopo, 5 marks are in the bag. 5 marks are inside. Okay. We are moving. It says, a chemist spills sulfuric acid of concentration of 6 mol per decimeter cubed from a flask on a laboratory bench. She neutralizes the spilled acid by sprinkling sodium hydrogen carbonate powder onto it. The reaction takes place, and the reaction that takes place is assuming that H2SO4 ionizes completely. And there is the reaction that was taking place in the balanced equation. The fizzing due to the formation of carbon dioxide stops after the chemist has added 27 grams of sodium hydrogen carbonate to the spilled acid. Then they say calculate the volume of spilled sulfuric acid, assuming that all the sodium hydrogen carbonate reacts with the acid. Like I said, out of this 6 marks, we need to know how to calculate number of moles. Just calculate number of moles. For sulfuric acid, we don't have much. We only have its concentration. We don't know what was its number of moles. We don't know what was the volume. So we only have what we have right now, which is concentration. However, for sodium hydrogen carbonate, we do have its mass. Now, we calculate its number of moles. Calculate sodium hydrogen carbonate's number of moles. That will be number of moles equals to mass over molar mass. And then from there, it will be molar ratio. You use molar ratio, 1:2. There, it says 1:2 is the molar ratio. 1:2. We use that molar ratio to determine the number of moles of sulfuric acid. And then from those number of moles of sulfuric acid, we then are able to calculate now its volume. We'll be able to now calculate its volume. But we said we are not going for the difficult stuff. Right now, we just do the basics. This paper that you're going to write, we want you to know the basics. So do the basics right. Calculate the number of moles. We are not looking for 6 marks. No, we just want to see if we are able to do grade 10 and 11 things. Let's just get those out of the way. So calculating number of moles from mass, grade 10. We should be able to score marks on it. Using molar ratio to determine the number of moles of sodium, of sulfuric acid, we should be able to get that as well. And then maybe we can struggle with getting volume, but we should be able to do those. And this 6 marks was easy because they already given them concentration. It was C is equals to N over V, the final answer there. That's where you will get your volume at the end of the day. So we'll check how much we would have scored from just that. Remember, we already have 5. So we're going to check how much we would have scored from just doing that. The chemist now dilutes some of the 6 mole per decimeter cubed sulfuric acid solution in the flask to 0.1 mole per decimeter cubed. Now, the chemist now dilutes. You see, it's changing concentration. That means by increasing volume, dilutes, increases volume. Right. And the concentration now becomes 0.1 mole per decimeter cubed. Calculate the volume. Calculate the volume of that was needed to prepare that. Now here it is obviously a question of, do you have number of moles? Remember, number of moles remain the same. So the formula that we use will be CV before is equal to CV after. This is also from grade 11. Now, CV before is equal to CV after because number of moles remain the same. And what do we have for that? We have concentration before, which was 6. Concentration after is 0.1. Now, the volume before, we calculated it from here. And then volume after, they say they want 1 decimeter cubed, so we have the volume after. We want the volume after is 1. The volume before, then we can get it from here. That's the volume that we can get. So 2 marks easy. It says during titration, 25 centimeter cubed of the 0.1 mole per decimeter cubed sulfuric acid solution is added to an Erlenmeyer flask and titrated with a 0.1 mole per decimeter cubed sodium hydroxide solution. The chemist uses homothermal blue as an indicator. What's the purpose of the indicator? What is the purpose of this indicator? The purpose of an indicator is to show us what? The end point. There. It shows us the end point. It shows us the end point. Good? Okay. So this is also a definition. So that means 1 mark must be in the back there. Then they say calculate the pH of the solution. We'll worry about these ones when we get to the final paper. For now, let's get the easy ones out of the way first. So we said 5 that other side. Yeah? So that was 5 plus. We said we get 5 here. That's 5 plus. And then 2, grade 11 plus. And then from 6 here. From 6 here, we should be able to get at least 3. And then plus 1 there, we should be at the answer, and we get 11 out of how much? 22. That's 50%. We get 11 out of 22. That's 50%. Let's see if where there were answers there. Yeah. That will be the memorandum to what we were busy with there. That is the memorandum to what we were busy with. And it shows the endpoint was where we were talking about as well. Okay. And then this is for calculation of pH of the solution. I'll try and post steps on how to calculate pH of the solution. Okay, let's see. This is another preparation question of a total of 16 marks. Like last year, this was from Northern Cape, if I'm not mistaken. Yes, that was Northern Cape's preparation paper. Okay, so let's see in Northern Cape, would they been able to get 50 plus? We saw Free State, we are able to get 50 plus with my strategy. We saw Limpopo, we were able to get 50 plus with my strategy. So let's see if we were able to do the same in Northern Cape. The first thing in Northern Cape they asked was, define a weak acid. They say hydrofluoric acid is a weak acid. Define a weak acid. We said it's a must know. So we already know that it's a substance that ionizes incompletely. Now, to create a low concentration of hydronium ions. So we know 2 marks is in the back. Fine. A sample of hydrofluoric acid has pH of 4,5 at 25 degrees. Remember, I told you, the moment you see 25 degrees, the examiner wants you to use kW. Okay. And then they said calculate what? Concentration. I said it's a must know. It's a must know. So that means we will be able to score 5 marks out of the way. Then it says when hydrofluoric acid reacts with sodium hydroxide, sodium fluoride is formed. What was formed? Sodium fluoride. But what's reacting? A weak acid with a strong base. A weak acid with a strong base. Now, then they're asking, will the pH of sodium fluoride solution be greater than 7, less than 7, equal to 7? Give a reason for your answer. This is hydrolysis, and we did already say, if a strong person fights with a weak person, the strong one wins. So that means the solution will be basic. And where is base? Greater than 7. Now, and give a reason for your answer. The reason is that one. We are reacting a strong base with a weak acid. Fine. So that means 2 marks also inside the bag. That will give us 7. And then they are moving and saying, in reaction A, 3,5 grams of pure MgCO3 reacted completely in 50 centimeter cubed of hydrochloric acid. The balanced equation for the reaction is given below. There we have it. But what did we have? Pure. They said pure. They gave us mass of that. So for this alone, we are able to calculate number of moles. Okay, 10. We are able to calculate number of moles. Yeah? And then react completely, that's titration, with 50 of hydrochloric acid. Okay. And then they say the excess HCl. Sorry, let me drink some. And then they say the excess HCl neutralizes exactly. Jaco? Unmute. Okay, Jaco, while we are waiting for you, let's move. The excess hydrochloric acid neutralizes exactly 20 centimeter cubed of a sodium hydroxide solution with a concentration of 1,2 mole per decimeter cubed in reaction B. And then they say calculate the number of moles of hydrochloric acid reacted in reaction A, and then calculate the concentration of the original solution of hydrochloric acid. Jaco raised a hand. I don't know if he's able to talk. Okay. I think you are sorted. Okay, fine. Let's move then. It says calculate the number of moles of hydrochloric acid that reacted in reaction A. We already know that hydrochloric acid was in excess, but we want the one that reacted here with magnesium carbonate. Magnesium carbonate now in this reaction is our limiting reagent. So that means we are able to get that using molar ratio. We just say number of moles. Maybe Jaco wants me to start writing answers before. So that will be number of moles of MgCO3, and that will be 3,5 divided by the molar mass there. Let me see if I have a periodic table with me quickly here. Can you help me out with the molar mass of Mg? I don't have a periodic table with me here, and it's going to take me time if I want to open it. Somebody just tell me what's the molar mass of Mg?
Mg?
Yes.
24.
It's 24 cell.
24.
Yes, sir.
Thank you. What would be the sum there? What's the answer? When I press my calculator, it says the answer would be 0,042 moles. Okay, so from there, we just use molar ratio. That is 1:1 molar ratio, 1:2 rather. So that would be 1:2. And what I have is for one, that is 0,042 is to unknown. Then I cross multiply, and number of moles now of HCl will be equal to 0,042 times 2, and I get the number of moles of HCl that reacted to be 0,084 moles. So I would have managed to get 3 marks here. This is just from grade 10. Just from grade 10. This is what we do in grade 10. Okay. And then the last question there says, calculate the concentration of the original solution. The concentration of the original solution. Yeah, it's 6 marks. It's a very long question answer, but like I said earlier, this question is called back titration. It's called back titration. So back titration is very nice, very nice. Now we said excess is neutralized here. So we now need to find out what was in excess. To get what was in excess, we need to calculate the sodium hydroxide that reacted. And for sodium, we were told 20 centimeter cubed of sodium hydroxide solution with a concentration of 1,2 was reacting. So that means number of moles of sodium hydroxide will be concentration times volume, which the concentration is 1,2, multiplied by the volume, which is 20 times 10 to the power negative 3. And we get the number of moles for sodium to be 0,024 moles. This is for NaOH. Now that we have that, we are going to use molar ratio. And if we use molar ratio, we can see that's 1:1 molar ratio. So that means the number of moles of HCl, and it's important, write in excess so that you do not get confused as well, is equal to number of moles of HCl in excess will be equal to 0,024 moles. Why? Because we have 1:1 molar ratio. Fine. I hope we are fine. Okay. Then to get the initial number of moles of HCl, initial number of moles of HCl will be equal to number of moles that reacted plus number of moles that was in excess. So what reacted? We calculated reacted this side here. Reacted 0,084 with what was in excess, that is 0,024, and that gave us an answer of 0,108 moles. So that was the initial number of moles. They want concentration. They are asking us to calculate concentration. So we now know what started, but we did know the volume that was used. And the volume that was used was 50. So to calculate concentration, we say number of moles divided by volume. This will give us 0.108 divided by 50 times 10 to the power negative 3. And we get our answer there. The concentration of the solution was 2.16 mole per decimeter cubed. Okay. That was a very lengthy question. That was a very lengthy question on bed titration, which is why I said, let's not worry about these long questions. Don't worry a lot about long questions. Just get your confidence right. So how much were we able to score? That was 5 plus 2 plus 3. 5 plus 2 plus 3. That is 5, 7, 10. So we're able to get 10 out of 16. That's way above 50%. So if we went to Northern Cape and we wrote a paper there, we would get more than 50%. We have received more than 50%. Okay, let's look at another province quickly, but here is the memorandum. If you want this presentation, just tell your teacher to arrange for you. You can get these questions for you to go through them also on your own. They can just send a message and the presentation will be shared with you. Okay, I think we got most of the answers right here. So let's move. Where are we right now? We are in MNED, Metropolitan. Okay, let's look at what they asked last year. We are still using my strategy of getting the easy answers out of the way. It says, define an acid according to Loribot's theory. Yes, Ukanyo, secondary school. We can unmute.
Sorry.
Yes, sir.
I'm still confused, sir, about something. Can you get back to the question?
Okay, the previous one. This one.
The one we did recently.
Yeah, this is the one that we just answered now.
No.
Earlier. Maybe let me go
Yeah,
back.
this one.
Yeah.
This one.
Okay.
You see 7.1.2. They said that we must calculate the concentration.
7 point? 7.1.2 or 7.3 maybe. Which one?
7.
This one?
There's the question that says is no, this not this one. Let's see. Actually,
So pay attention to
The one that wanted us to calculate what? Maybe that will help me faster.
the one that wanted us to calculate the concentration. They gave us the pH.
Oh.
Yeah.
Okay. Oh, so where they gave you pH and then you have to calculate concentration. Is that what you are saying? Like this one?
Yeah. Yes.
Like this one? Like this one? The one that I'm highlighting right now, like this. They gave us pH and then they want us to calculate concentration of hydronium ions.
Yes. I believe the pH was 4.5.
Yes. There it is.
Yes.
Or should we attempt this?
Yeah, I'm still struggling. How did we calculate the concentration of hydronium ions? So like,
okay.
Even formula. So if you can just quickly
No.
do step by step, maybe I can understand much better.
Okay, no, let me do that then. Stay with me, ne? Because I'm gonna
Yeah.
try and communicate with you. Okay, so what we are given is that pH is equal to 4,5. I'm right?
Yes.
Okay, so the one concentration of hydronium ions. What we must note, and we are running out of time, I just wanted to highlight, we must know that the temperature is 25. Ne? In your data sheet, you must have this formula that says times the concentration of OH minus is equal to 1 times 10 to the power negative 40. It must be there at 25 degrees Celsius. It must be in your data sheet. Okay. What is reacting? We are reacting HF with water. Fine. So HF is going to donate a proton, and we are going to have H3O plus F minus. So that will be the complete reaction. And in this complete reaction, what we can see is that we have 1:1 molar ratio. We good? So to get the concentration of hydronium ions, this is just an easy one actually, but I will try and do another one where you will see the purpose of everything that I've wrote there. pH is equal to negative log concentration of H3O plus, and pH is 4,5 is equal to negative log, and that is still concentration of H3O plus ions. Okay, so from here, we have to go to mathematics. In mathematics, this is where you do it. They say y is equals to 10 to the power of x. Ne? And then we interchange the position, and then we say x will be equal to 10 to the power of y. Remember, and that's where we say y will be equal to log base 10x. So we are just moving from here back there. I hope you are with me.
Yes.
You are with me, ne? Okay. So our base is 10. So to get, this is, remember, this guy. We must be able to see this guy there. Ne? Okay. Our base is concentration is X in this instance. So that will be H3O plus is equal to 10 to the power. We're going to multiply with a negative sign on both sides. So 10 to the power negative 4,5. And that will be your concentration in moles per decimeter cubed. So all you need to remember, all you need to take note is that interchange in there. And it is best actually before you, but I think you did it when you were busy teaching acids and bases, how to move from log back to exponential.
Yes.
Does it make sense?
Yes.
Are you sorted now?
Yes.
So I can move forward.
Yeah, you can. Thank you very much.
Thank you, sir.
Thank
Okay, we have a few minutes left, very few, about 4 minutes left before I go. So I just wanted to check for you so that we are certain that this is what we are going to do in preparation for our examination. Okay. The question says define, that's 2 marks. Yeah? Calculate concentration of hydroxide ions present in the solution after hydrochloric acid was added. I would love to try this, provided that you guys will help me in this 4 minutes, because it's similar to what we just explained right now. The use of autoionization. If you guys would help me, I would try for us to quickly explain this for you. So they're saying We should calculate the concentration of hydroxide ions present in the solution after hydrochloric acid was added. We will not be able to do that, unfortunately. The next teacher is already here, but we should be able to calculate number of moles. The most that we can do, we should be able to calculate number of moles. And that would be at least 2 marks. And then from there, they are asking to suggest an indicator, and the possible indicator there, they are saying for 1 mark. And then they want us to calculate answer. They want us to refer to the strength of an acid and the base to predict why we are saying the pH, as well as the pH to explain why we are using this indicator. So what we can see is that we are reacting as strong with the strong. I think I have a hand. If you can unmute yourself. But this answer here is one of the things that we said we must be able to know. So that would be 2 plus 2 plus 4. So that's 4 plus 4. That will give us 8 out of 18. Yeah, that would give you 8 out of 18. That's roughly 50% of this question. So what I'm saying to you in closure, as I wrap up, what I'm saying to you is this. Do not try and get yourself conflicted, trying to figure out how to learn the difficult things at this stage. What you need to do is to get the easy stuff first. Be comfortable with what is easy. If you can get comfortable with what is easy, then getting to what is challenging would be easy as well. It would be a smooth path. So for this term, for this trial examination, ensure that you are comfortable with easy. Don't worry about difficult. You still have time. Yes.
Since you won't be able to do these questions, could you please tell us where we can find this example?
Slide. Yeah.
This example.
Okay. The slides will be sent to your schools. Ne? Just when I'm done here, I'm also going to ensure that they do send it right now. So it will be sent to your schools or in your WhatsApp group. Do they have WhatsApp groups? Okay. It will be sent to your school and then you will communicate with your teacher. Ne? Is it fine?
Yes, thank you.
Thank you, my love. So please get comfortable with the easy stuff. And then when we prepare for final, I'll come back for us to go back. Now I will give you steps on how to get these 7 marks out of the way. I will help you with those. But first, let's get the easy stuff out of the way. I hope you and I had a great time. I enjoyed my session here. I hope you also enjoyed the session on your side. And I hope you also do what I'm asking you. Please trust me. I've been doing this for a while. Just do this. You will see by the time we get to November, you'll be comfortable and you will also manage to get a decent percentage on your final. And thank you for being here. God bless. Goodbye.